day, my dear students! Welcome to Bamboo Telescuela. I am teacher Edeline, and this is your school on air in Science A. Make to have review your modules and find comfortable place. Check your speakers if you can hear me clearly. I encourage you to place a notebook, ball pen, and stay tuned to DWND FM at CMD Cable Vision Channel 8 and streaming live at SDO Cauayan City Facebook page. Today, the highlight of our discussion is about the Newton's law of motion. As you go over the activities in your module, you will be able to infer when a body exerts a force on another, an equal amount of force is exerted back on it, and explain the laws of motion. But before you move on, try to find out how much you know about the Newton's law of motion by answering what I know on page 2 and 3 of your module. Read the direction and try answering the multiple choice question. Write your answer on page 2 and 3 of your module. For those watching, you can see the question on screen while I will use dictation for those who are listening. Be honest in checking your answers because the answer will reveal after 10 seconds. Are you ready? Have fun and good luck. Let's begin. Number 1. Who formulated the 3 laws of motion? A. Aristotle, B. Isaac Newton, C. Thomas Edison, and letter D. Alexander Graham Bell. The correct answer is letter B. Number 2. Which has more mass? A kilogram of cotton or a kilogram of iron? A. The iron, B. The cotton, C. They both have the same mass. Letter D cannot be determined from the given information. The correct answer is letter C. Number 3. Which has the greatest inertia? A. Airplane, B. Car, C. Jeepney, D. Bike. The correct answer is letter A. Number 4. Which of these vehicles moving at the same velocity is difficult to stop? A. A bus, B. A car, C. A train, D. A truck. The correct answer is letter C. Number 5. All of the following apply the third law of motion except A. Kicking a ball, B. Rowing a banka, C. Throwing a stone, D. Taking out ketchup from a bottle. The correct answer is letter A. What is common in the given situation? Look around you. What do you observe? How would you describe most of the objects that you see? What can you say about moving vehicles and running animals? Have you ever asked yourself what causes these things to move? How will the world be without motion? Such an interesting topic, right? This time, let's know more about science behind the development of forces and motion. Motion has been studied for centuries by many great minds. First, we have Aristotle. He introduced the idea of impetus that keeps a body in motion. Number 2. John Philoponus. He first introduced the theory of impetus, a concept similar to force. According to the theory, when impetus decreases, the speed of the object also decreases. When that impetus is removed, the object stops moving. Number 3. We have Jean Buridan. He developed the theory of impetus introduced by Philoponus. Number 4. We have Galileo Galilei. disagreed to Aristotle. He claimed that even without continuous application of force, an object can continue to move with constant speed in a straight line, provided there are no outside forces acting on it. Finally, Sir Isaac Newton used Galileo's ideas and eventually formulated the three laws of motion. Now, refresh your memory by doing the next activity. Kindly turn your module on page 7. The objective for this activity is to be able to understand the timeline of the significant development of the concept of force and motion. In the direction, in each number, match the scientists who spoke the corresponding dialogue on the right side. Write the letter of the correct answer on page 7 of your module. Don't you worry, you are given ample time to answer the activity because you have with you your modules. Go over and answer it later on. Today, we will have a very informative discussion regarding Newton's law of motion. Are you ready to learn more? There are three Newton's law of motion. First, law of inertia. Second, law of acceleration. And third, law of interaction. How do common experiences help us to understand Newton's first law of motion? To answer this question, let's watch this video.
Today, we will learn about Newton's first law of motion, or law of inertia. There was this fellow in England named Sir Isaac Newton, born in Woolsthorpe, England on January 4, 1643. This extremely talented guy doesn't need any introduction. While working, he came up with the three basic ideas that are applied to the physics of most motion, excluding modern physics. The ideas have been verified and tested so many times over the last years that people now call them Newton's laws of motion. Let's learn about Newton's first law of motion. This is also called the law of inertia. Newton's first law of motion, or law of inertia. This states that there is a natural tendency of all objects to keep on doing whatever they are doing. All the objects resist changes in their state of motion. In the non-existence of an unbalanced force, an object in motion will continue this state of motion. See this ball sitting in your table? It is not moving, meaning it's in the same position. When you push it with a finger, it starts rolling. Ah, see, it's not stopping. Oh, this book came in its way. It will stop now. This clearly means that moving objects do not change their route or direction unless a force causes them to move from their path. Let's take one more example. Imagine you're in space and you kicked a ball. It will keep moving forever and forever because there is no force or blockage to stop this. Come on now. Let's try to move this large couch. It's not moving. Is it stubborn? No, because the force you applied is not enough to move this big couch. But you can move this chair easily, because the effort you are putting is enough to move this. Newton's first laws state two things. A stationary object will move only if there is any unbalanced force acting on that. A moving object will change direction or speed only if there is any unbalanced force acting on that. Now, you understand Newton's first law, or law of inertia.
Based on the video, which has more inertia? A mouse or an elephant? The first law of motion is also known as the law of inertia. It states that a body at rest will remain at rest, and a body in motion will continue to move with a constant velocity unless acted upon by unbalanced force. A common example where inertia can be observed is when you are riding on a bus. Imagine you are riding a car and make sudden U-turn. How will your body move? Yes, it will move outward. Why will it move outward? Correct! Our body is at rest because the forces acting on the body is balance. How about when the car suddenly stops or hits a big object? How will our body react? Excellent! Our body will tend to move forward. Now you can explain why seatbelts and headrests are provided on the cars? Brilliant! We are advised to put on our seatbelts when we are riding a car so that when accidents will happen, our body will not be thrown out. Another law of motion is the law of acceleration. To find out what the second law of motion is, please watch this.
Now let's move on to Newton's second law. As we know from the first law that to overcome the inertia of an object, we have to apply unbalanced force. Newton's second law talks about how fast an object would move. Well, it states acceleration of an object depends on the mass of the object and the amount of force applied. In mathematical terms, Newton's second law states that force is the product of mass and acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Look at these two swings. If you apply the same force on both swings, check whose goes faster. Let's first push the little kid. See? It goes very high. Now push this fat man with the same force. See, it does not go far, because it has more mass than the little kid. So the more mass there is, the force required to push the object is also greater. Let's look at the mathematical formula of the second law again. It's the product of mass and acceleration. We've already learned that if there's more mass in an object, to move it, we need more force. Now let's see this kid sitting in the swing. If we apply little force, then it goes a small distance. Now if we apply a lot more force, it goes very high. So to get more acceleration, we need to apply higher force. So now you can understand the relation among force, mass, and acceleration.
The second law of motion, or the law of acceleration, states that the acceleration is directly proportional to the net force and inversely proportional to the mass. Take a look at this picture. Compare the acceleration of the shopping cart for different loads. What relationship exists between the acceleration and the mass? Nice observation! You observe that as the mass of the object increases, the acceleration decreases when the force applied is made constant. We can say that the acceleration is inversely proportional to the mass of the body. How about this one? This time, compare the acceleration of the shopping cart for different forces. What relationship exists between force and acceleration? Amazing! You observe that for a given mass, the acceleration increases as the force acting on the body increases. We can safely say that if the mass is constant, the acceleration of a body is proportional to the force acting on it.
Newton's second law of motion is expressed through this equation. F is equal ma, where sigma stands for the algebraic sum. Sigma F stands for the net force acting on the object, and it is measured in units of Newton. M for mass of the object, and it is measured in units of kilogram. A for its acceleration, and it is measured in units of meter per second squared. The arrow above the letter F and A indicates that both have magnitude and direction. Now let's try to apply the second law of motion using the given formula. In solving problems involving second law of motion, it will be very helpful to follow these steps. First, identify the given and unknown. Second, write down the equation needed to solve the problem. Third, substitute the given or known along with their units into the appropriate equation. Fourth, solve the problem carefully and enter numbers into your calculator. Remember, make sure that all of your numbers have the correct SI unit label and always recheck your answers. Now, let's apply the procedure. Sample problem 1. A 1,000 kilogram truck is traveling at an acceleration of 4.5 meters per second square east. Find the net force needed to accelerate the truck. Let's apply the procedure. Sample problem number 1. In the given problem, mass and accelerations are the given, and the unknown is force. Mass is 1,000 kilogram. Acceleration is 4.5 meters per second square. The unknown is force. If force is unknown, the equation is F is equal m times A. Substitute the value of mass, that is 1,000 kilogram, and acceleration is 4.5 meters per second squared.
Before we proceed to the next law, let's watch another video.
Till now, we've only learned the first and second laws of motion. Oh, you're riding a bicycle. Have you ever wondered why a bicycle moves forward? Well, it moves according to Newton's third law, which says that for every action, there is an equal and opposite reaction. To understand this, see what happens when you drop a tennis ball. As the tennis ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction. Action, reaction. Together, the floor and the ball form what's called the action-reaction pair. So now how it applies to your bicycle. When you push the pedal, the parts of the tire which touch the ground push it backwards. The ground also pushes the tires forward with the same force. So the parts of tires and earth form a pair of action and reaction. So what happens to the earth when your tires are applying force to push it backwards? Huh? Oh, nothing happens to it since the earth is very big as compared to your bicycle. The force applied by your tires does not move it backwards, but force applied by the earth pushes your bicycle forward. So now you understand Newton's third law. Yep, the tennis ball is the right example. The ball and the floor are creating a pair of action and reaction.
What does the third law say? This law states that for every action, there is always an equal and opposite reaction. What does it mean? This law tells us that the force exerted on any object is always exerted back by an equal magnitude of force but in opposite direction. For example, according to Newton, whenever objects A and B interact with each other, they exert forces upon each other. When you sit in your chairs, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. For example, a boy pushing a wall. What is the action in the given situation? You are correct. The action is when the boy pushes the wall. How about the reaction? Impressive! The wall exerts an equal and opposite magnitude of force to the boy. Always remember that in this law, forces always come in pairs. These are called action and reaction forces, and they do not act on the same body. Forces will only cancel if they act on the same object. This time, let's talk about force of gravity or weight. In one of Galileo's experiments, objects dropped near the surface of the earth would fall with the same acceleration if air resistance is neglected. This acceleration is denoted by g, or acceleration due to gravity, with an approximate value of 9.8 meter per second square, or 980 centimeter per second square, or 32 feet per second square. The force that causes these accelerations is called the force of gravity or gravitational force. The force acts vertically downward toward the center of the earth. Now it's time to put together what you've learned. Here are the keywords you will remember a while ago in the discussion. Here are the three laws of motion. First law of motion, or law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by unbalanced force. Second law of motion, or law of acceleration, states that the acceleration is directly proportional to the net force and inversely proportional to the mass. What does the third law say? This law states that for every action, there is always an equal and opposite reaction. See you on our next learning, same time, from 11:30 to 12, here only on DWND FM. Remember that education must continue amid the crisis. Once again, I am Teacher Edeline L. Martinez for Bamboo Telescuela, bringing education in the comfort of your home. Goodbye!